Hello, class. I hope you enjoyed the weather this weekend and had a nice weekend. We're going to continue talking about weather this week. We've talked about cloud formation and air masses, and this week we're going to start talking about fronts. Uh, Next week we're going to get into weather maps, things like that. So this week we're going to start talking about fronts, and we're also going to celebrate the 50th anniversary of Earth Day and what that means for you guys. Let's get started with our notes on weather fronts. So fronts, if you look on a map, like when the weatherman shows you, they are these red and blue lines on your weather map. So here would be a cold front, this blue one, this red one would be a warm front. So we have a few fronts here over North America as of this evening on April 19th. So what is a front, you might be asking? Well, a front is simply a boundary between two air masses of different densities. Now, these air masses that we talked about last week, they all have different properties, right? Some have more water vapor, some have are drier and colder. So what it boils down to is this. Colder air masses, like your polar air masses, are dense, very cold. Your molecules are closer together, and your warm air masses are less dense. Now, when these air masses meet each other, they do not mix. So instead of mixing, they form these boundaries called a front. So a front forms instead of these air masses mixing. These fronts can be hundreds of kilometers long or hundreds of miles long, and they bring your changes in weather. So if we look at our map here, these fronts are super long, hundreds of miles. This goes from the middle of Idaho to the western end of Nebraska. They're very big. That's not even a big one. Here, this cold front goes from Indiana all the way up to Quebec. It's gigantic. A few different types of fronts that we can talk about. And the first one we're going to talk about are cold fronts. Now, a cold front is the forward edge you can think of a cold air mass. If you look at the picture here, this cold polar air mass you can think is the one moving. This cold air mass is moving forward, and this front edge is the cold front. The cold air mass pushes underneath the warm air mass. Here you can see the cold air mass is pushing, the warm air mass is going on top of it. So the cold is pushing over underneath the warm air mass. As it goes forward, this warm air, because it's less dense, it's lighter, you can think, gets pushed up really fast. So this front edge, you can think, is going underneath the warm air, and the warm air is getting pushed straight up. Okay, the cold is going underneath the warm. This cold front brings like your thunderstorms, brings a lot of wind and rain and cloudy skies. Your big cumulonimbus clouds, cumulonimbus happens at these cold fronts because the warm air is getting pushed up so fast that it cools off and can't hold all the water that it has, and it just drops, right? We have all the rain, we have thunderstorms, things like that. After this front passes, the cold air moves in. So you can think of, if you were going to stand right here on this line, as the cold air moves moves forward, it's going to get colder. I'm going to show you a quick animation that kind of shows how a cold air mass creates its weather. So as you can see here, the cold air mass is moving forward. It's pushing that warm air up. That warm air is cooling off, right? It's creating clouds, really big cumulonimbus clouds that create these big thunderstorms. So the other type of front we have is a warm front. And this is where the warm air mass is moving over the cold air mass. So the cold front is where the cold air mass is moving. The warm front is where the warm air mass is moving. Now, warm air is always less dense than cold air, so it's always going to go over the top of the cold air. So here, your warm air is moving over and on top of the cold air. Now this grade, this steepness, is very shallow compared to that cold air mass where it was really steep. This is really not that steep. It's a much shallower grade. So it forms a gentle slope. So it's not making these big thunderstorm clouds. It's making a series of different types of clouds. So as this warm air is rising gently over this slope, some different clouds form. Way up here, you can think of those really high clouds from a couple weeks ago as those cirrus clouds. They're wispy. As the clouds are forming lower in altitude, you get your cirrostratus and altostratus, which are like your mid-level clouds. And then you have stratus and nimbostratus down here closer to the earth. This is creating rain. So these are slow clearing, and they bring warmer temps after they come through, and they take a while to come through. While the cold fronts take hours or minutes to pass through, the warm fronts take days or hours to go through, instead of the really quick thunderstorms like we get. So with the warm front, you have like days of cloudiness and days of rain, and then it gets warmer behind it. I'm just going to show you a quick animation that shows a warm front. So here you can see the warm air is moving over the cold air, and clouds are forming low, medium, and then high up here they form. So you get your cirrus clouds, your mid-level altostratus clouds. Remember, stratus means layered. These are your big layered clouds. And then finally down here you have your nimbostratus. So as the air moves up, it cools off and your clouds form. And at the lower altitudes you get rain, and then you just get big layered stratus clouds and cirrus clouds as you get higher in altitude. These don't create your big nasty thunderstorms like your cold fronts do. These are just like your dreary rainy days. So let's see the animation here. So the air is moving up and you have your clouds. And then this is the cirrus. As it moves on, you're going to get, like I said, you're going to get your layered altostratus and then your nimbostratus clouds. Okay, so these are the big differences and takeaways I want you to get from this week's lesson. So we have more than two different types of fronts, but the two fronts we focused on are warm and cold fronts. So let's go over the cold fronts again. So the most important things are, with a cold front, cold air is moving underneath warm air, as you see here. It's pushing the warm air up a very steep gradient right up this curve. It passes in hours or minutes, and it's followed by cool temps. Okay, so this air is moving forward. After it moves through, it's colder. Like I was saying, it shoots the warm air very steeply. It shoots it straight up, and it causes cumulonimbus clouds. Think thunderstorms. So your violent thunderstorms that pass very quickly are associated with cold fronts. Now, on the contrary, we have warm fronts. This is where the warm air is moving over the cold air. So the warm air is moving. This passes in days, not minutes. It takes like a day or a couple of days for a warm front to come through. After a warm front goes through, it's usually followed by warmer temperatures, because the warm air is moving through, and behind that warm front is the warm air. With a warm front, the warm air climbs a gentle slope, not a steep slope like the cold front. It goes up a gentle slope, and it causes a few different types of weather. It starts out with cirrus clouds are going to be up here, so your thin wispies. And then it's going to be thicker stratus clouds or altostratus clouds in the mid altitudes. And then as the warm air or the warm front progresses, it's going to be your nimbostratus. So these are like your dreary, rainy, layered clouds. These are like your dreary, rainy days. And these take days to go through, not minutes. So think your sprinkly, rainy days that take, like all day it's raining. That would be a warm front. So the other thing we're doing this week, and how we're going to finish out our lesson this week, is by celebrating Earth Day. So every April 20th, we celebrate Earth Day. And what is Earth Day celebrating, you might ask? Well, Earth Day is mostly, it demonstrates support for environmental protection. So things like action on climate change, things like cleaning up pollution, habitat or reversing habitat loss, things like that. That would be all things related to Earth Day. So this year is actually the 50th anniversary of Earth Day. The first Earth Day happened 50 years ago in 1970, April 20, 1970. And this year's theme for Earth Day is climate action. So we're going to be looking at a couple of different ways, or we're first going to be looking at what our carbon footprint is. I did this activity and I found out that my carbon footprint is, it would take almost 4.5 Earths. If everybody lived on Earth like me, we would need 4.5 Earths to sustain us. Obviously, we don't have 4.5 Earths, so I'm going to take some action with my life to hopefully bring down my carbon footprint. You guys are also going to be figuring out what your carbon footprint is. I've uploaded the assignment for that on this Google Classroom assignment. So you're going to be figuring out what your carbon footprint is and maybe a couple of actions you can take to lessen your carbon footprint. The other thing I'm going to ask you to do is go outside on a 15-minute walk and pick up trash. If you send me a picture of trash and upload it to the Google slide that I have on this Google assignment, if you upload a picture of the trash that you picked up on your walk, you'll get 3 extra credit points. And that doesn't seem like a lot, but it actually, because we don't have that many assignments yet, it could bump your grade up by a whole letter grade. So if you guys, so I'd like for you guys to go to this website, figure out your carbon footprint, figure out what you could do to maybe be more sustainable. And then the other thing I'd like you to do is go out and just pick up a little bit of trash. So thank you guys for sticking with me on this lesson this week. And I hope you have a great rest of your week. If you have any questions, I'm going to hold a Google Classroom, or not a Google Classroom, but a Google Meet. So you guys can ask me any questions. Just hop on the video, or you can just drop by and say hi. The other thing you can always do is just send me an email. I'm usually pretty good if it's during school hours, so like 7:30 to 3:30. I'm going to be right next to my computer probably. I'll send an email right back. So I hope you guys have a great rest of your week, and keep in touch.